Hi everyone, this is Dikshit. Welcome to my channel. In this particular video, we will going to discuss about use cases of Lambda functions, which I came across in current or a previous project. And this video can help somebody who's searching opportunities in DevOps area or who are already into DevOps, but they want to understand different use cases, challenges, and scenarios. Then this video can benefit them as well. So before moving ahead, I have a small request. So this is the screenshot that I've taken from my YouTube analytics. I see that 75% of my viewers have not subscribed to channel. If you consider subscribing to my channel, so then it will definitely motivate me to do more and more videos like this. Now, without wasting any time, let's get started. First use case that I want to discuss is related to AWS Cast Report. So in one of the organization where I was working for a big client where they had multiple projects, I was part of one of the project where we wanted to kind of host CI/CD tools like Jenkins, SonarQube, Artifactory, SCM, and other CI/CD tools like Grafana, Prometheus, and many other as well. And in this client, they were using AWS as a cloud. And as to host these particular CI/CD tools, we wanted to have a AWS account, our own AWS account for this particular project itself. And that is where we wanted to kind of host all these CI/CD tools. And in this client, they had a certain process whenever we want to get a AWS account. So we need to send our request with all the requirement, with all the approvals to the AWS admin team. And this admin team was part of client office itself. And then they're gonna check whatever the requirements that we have provided, and they're gonna check whether this is really required or not. And post that, they'll also get the approval from their management, and then they used to create a sub account. Once they give a sub account, and then they'll also give you rules to kind of create the services that you require to host the applications, whatever that you require. And we had got that particular rules, and we started creating the resources. And you can see on the screen, these are the services that we had used like EC2, S3, EKS, ECS, ELB to create or like to host our CI/CD applications. And once we had hosted and everything came up and we had shared information with our application developers as well, they consumed our CI/CD tools and they were kind of running their pipelines. And it was really going fine. But sometimes what we used to get is like from the admin team. So we used to get a notification that you're over-utilizing the resources because whatever the budget that we have allocated to this particular account, it has been more than that. What does that mean is whatever the cost that is happening for these particular infrastructure is more than whatever admin team has allocated to us. And with that, we used to get the report saying what are all the resources that we had used and for each resource, like what is the cost, all that information we used to get it. And so that's where we decided to kind of adopt a few FinOps methodologies, or we implemented few FinOps activities in the project and we started implementing that. And once we started implementing that, we wanted to get that particular budget report on a daily basis because we want to check whatever the implementations that we did, whether it has really reduced the cost of the infrastructure or not. And to get it on a daily basis, we didn't add access to that particular budget report with whatever the roles that we had provided for this particular sub account. And to get that budget report, we used to raise the request to admin team, and then they used to take some time and then share back the budget report. So that is how it was really working, and which was really difficult for us to monitor it. The activities that we have implemented, whether it is really reducing the cost or not. That's where we requested admin team to provide one admin user where we can check the budget report of only this account. And they rejected that particular request, saying that this is against their policy. They can't provide that access for a user. But they mentioned that they can give a specific role, IAM role, where you can attach that particular role to some instance where you can run some Python script and get that particular budget information. So that's where we came up with a plan that we will gonna create a Lambda function where it will gonna run on a daily basis. Daily once it will gonna run. What it does is it will gonna get the information about the billing report of this account because it had a role. We used to attach a role where admin team has provided to this Lambda function so that it can access the budget information related to this account. And it segregates according to the service and what is the cost which has happened in the last one day, and it will going to segregate it and in clean table format. So it used to generate a report. And that report, initially we used to send it over an email by using SNS service. But later, in a mail, it was not many people were like not able to check it or keep track of it. So that's the reason we created a Teams channel where on a daily basis we used to send the reports on this Teams channel. So this is how whenever we implement it, and the next day we used to know whether the infrastructure cost has been reduced or not. All those kind of things we could able to check it easily, and also we need to kind of we had a idea like how much we are using, and we used to keep an eye on like how much we have used. So this is where we had used a Lambda function to get or to automate the cost report on a Teams channel. So we had used a Lambda function. And not only in this situation, so I've seen in multiple other projects as well. So always managers or leads will ask like, can you give me the last month's report? So because they will be involved in a lot of activities, they might not have a time to go inside AWS account and check the reports and all. So that's the reason if you implement this mechanism, they can easily check, keep track of what is the budget or cost infra that we are using on a daily basis or a monthly basis. They can easily track it and it's easy for them to check it. So if we have this particular implementation. Second use case that I want to discuss is related to alerting. So in one of the project, I was responsible for creating a GitLab CI pipeline for multiple application teams. So multiple application teams as in multiple repos, multiple pipelines based on commit level, based on merge request level. So there were so many pipelines that we were created for different application teams. And so that's where we wanted to kind of have a centralized dashboard to check regularly health of all the pipelines and also to capture number of pipelines that we run in a day, number of failed pipelines, successful pipelines, average time to execute the complete pipeline in each stage. Those granular level metrics also we wanted to capture it. And in GitLab, so there is no internal solution or a plugin that can support us to kind of provide status of multiple repo pipelines, and we had to go for each repo and check the pipeline status. So that used to be very difficult because as we were supporting multiple application teams or multiple repositories. And that's where we wanted to have this centralized dashboard, and we came up with a simple idea. So what we did is we created a simple Python script, and whenever this Python scripts will be invoked in this particular pipeline, so it collects the pipeline information like stage information, failure or success, duration of pipeline execution. It collects and it inserts the data into Postgres. And whatever the pipelines that we were supporting, so we invoked this particular Python script in a different stage. And whenever this stage executes, it collects the information, stores in Postgres. So this was kind of established. And then we wrote a very simple logic, HTML page, and with a very simple logic where it retrieves the data from Postgres and it shows some bar graphs, pie charts to check the health of each repos pipeline. So this was implemented, and here you can have a doubt that why not, like instead of writing our own custom application, why not we use like Grafana or Prometheus, which is open source. We would have used that, but what we had also in the mind was like whenever we use this open source, we need to regularly upgrade it and we need to adopt whatever the changes which will be there in the latest versions. All those management we need to do it, and it is also overhead. And only for this particular metric calculation, we didn't wanted to manage all that open source tools. So that's the reason we had written our own simple application where we had a simple dashboards. And this was fine. We were able to capture all these metrics and we could able to see it. But the problem was this particular application didn't had alerting mechanism. And sometimes we used to see that the pipelines used to kind of fail and developers used to block. And when they inform it, so then we used to take some action. And this was not correct. And it was impacting the developer productivity as well. So that's where we wanted to kind of have alerting in place so that whenever some builds fails or some number of pipelines fails, so it should be alerted to CI/CD team so that we will take a corrective actions as soon as possible to unblock the developers. And as we didn't add alerting system in this application, so that's where we wanted to use a Lambda function. And this Lambda function will run every 5 minutes. And once this Lambda function runs on a 5 minutes basis, so it retrieves the data from Postgres. And also we had one config file where we had mentioned what repo to monitor and how many builds it has to consider, and how many failed count. All that information we used to specify it in this particular config file. This Lambda function will read this config file, and based on the configs that has been provided, it queries the data in Postgres. And if number of failed count is more than whatever we specified in this config file, then it used to send an alert to CI/CD team in form of a mail. So then once that mail has been received by CI/CD team, so as soon as possible, they could able to kind of take a solution or action items on that particular pipeline. And this is how wherein like we monitored our pipelines even more with the effectiveness, and this could increase the stability of our pipelines, and as well as it improved the productivity of the developer. And this is where we had used Lambda function, where we kind of check the data of the pipeline, and then we create alerts in case of any issues in the pipelines. The third use case is transforming app data and storing it in database. So in one of the application, we had a small microservice. It was a feedback microservice where it has a web page where it will be shared across multiple customers, and where the customers can fill their ratings and some comments. And this application takes that particular comments and also ratings and stores that particular feedback as a JSON file in S3 bucket. And we had one more app, so where it will gonna read the data from this particular S3 bucket and applies some business logic and inserts the data onto database. So this was the procedure that we were following, and this particular app, it was retrieving the file for every 5 minutes and 10 minutes. That was the schedule time of it. And it was taking a lot of time to kind of retrieve the data from S3 and apply business logic and inserting it to database. So we wanted to fasten this particular procedure because the data which is there in this DB was used by multiple other applications. So we didn't want it to have any delay from this app to the database insertion. So that's the reason here we wanted to kind of use a Lambda function. So Lambda function, so in this use case where we can enable a event-driven trigger for Lambda. So as soon as file is updated or created in S3, we can create an event. Through that event, the Lambda function can be triggered. And in this Lambda, we can write a business logic, and then it can read the file and take a business logic and insert the data as soon as possible onto the database. So this is how we had used a Lambda function to read the JSON file and insert the data into DB as soon as possible, which increased kind of fastness to insert the data. So there are other applications could able to retrieve the data as soon as possible when it is available, and then they could able to retrieve the data as well. And moving on to the next use case, which was related to Jenkins. In one of the project, we were using Jenkins as a CI/CD tool. And in Jenkins, we had created a lot of pipelines, and many pipelines were interacting with different tools like SonarQube, Jira, Confluence, Artifactory, and some databases. Many different tools it was interacting. And if you want to interact with other tools, then we require username, password, or a tokens. And all these tokens were stored as part of Jenkins credentials. In Jenkins, we have a credentials feature, and that's where we can create a credentials of a string, username, password, different types of credentials are there. We used to store it there. But in this inbuilt credentials features of Jenkins, I had few issues. So that is one is like reading, verifying actual values in the credentials was difficult. And the other one is how do we protect the secrets? If somebody deletes it, then the pipelines used to kind of fail, and also we kind of can't revert or like recover that particular secret back. So that was one issue. And whatever the tokens that we had, or passwords that we had, so we had a policy in our project where that used to be expired in 30 days or 7 days. Different tools, different policies we had. So that time we used to manually rotate or like create a new secrets and update it into that particular credentials. And sometimes during this particular rotation, so you because of human intervention, it is very common that with the confusion we can update different values into different credentials. And all these were the problems, and we regularly could see that multiple issues because of these reasons. So that's where we had migrated our credentials, all the credentials to AWS Secret Manager. From the plugin, we used to read it and use it in the pipelines. So this was fine, and we could solve all these problems, reading and protecting our secrets and versioning our secrets, because if somebody has updated a wrong password, we could able to kind of revert it back to the previous password. All those things we could able to achieve it. And also very important is we need to kind of rotate it. In the beginning, we used to rotate it manually, but we wanted to kind of automate it. In this AWS Secret Manager, we had a functionality to trigger a Lambda function. So to rotate the secrets automatically. So that's where we had used this particular mechanism itself, where we used to have some particular schedule, and that particular schedule, the Lambda function will be triggered. And in this Lambda function, we used to have a logic to create a new secrets according to the tool and updates back that particular newly created token to AWS Secret Manager. And that's where even this kind of rotation of the secrets also kind of automated by using Lambda function, which kind of avoided a lot of failures of the pipelines. The last use case that I want to discuss is related to managing EC2 instances. In one of the project where I was working, so for few developers, we were providing EC2 instances because whenever they want to execute the builds in their local machine, it used to take a lot of time. And whatever the development they were doing, like it was slown up because the builds were taking a lot of time to test their features locally. It used to take a lot of time. So that's the reason to fasten their local builds, we had provided a EC2 instances. And also here we wanted one more feature to be integrated at developers local time 7 p.m. So we wanted to kind of switch off these EC2 instances. It's not like termination, it is stopping the EC2 instances. And here we had one challenge because we had developers from all over the world, India, Germany, US, China. And whatever the instances that we were creating, it was one region, but developers were there in multiple different regions. And we wanted a mechanism to stop in their local 7 p.m. So if it's a Indian developer, and then we wanted to kind of stop the CC2 instance 7 p.m. IST. And if it is US time 7 p.m., we wanted to kind of stop this particular instance. So that kind of a mechanism that we wanted. So that's the reason what we did in the beginning. We created an event bridge, 4 event bridges. One event bridge is for like India, it will be scheduled on 7 p.m. IST, and then it will gonna take whatever the instances that we have provided in this event bridge, and it will gonna execute a stop API, and it used to stop EC2 instance. So if you don't know what is event bridge, it's a simple service in the AWS where we can execute a simple APIs within AWS environment itself. Starting a EC2, stopping a EC2, deleting some file in S3, and small APIs like this, we can execute it as part of event bridge. And we had 4 event bridges, one for each region. So it used to get the instance IDs that user has provided, and it used to stop it. But here the problem is whenever we create a new instance, for example, let's say new developer has joined in India, we used to create a new EC2 instance, provide it to him. And when we provide this EC2 instance, in Event Bridge also we need to go and add that instance ID manually. Sometimes we used to forget, and so that's the reason instance was always in running state and it increased infrastructure cost. And so that's where we wanted to kind of handle it this particular situation bit better. So that's where we used a Lambda function. So what we did is, so first and foremost thing is we tagged all our instances with these particular tags. You can see that each machine that we had provided to developer is tagged with used for local build, and also which application team that developer belongs to, and also the region. So you can see that if it is from China, it is CN, India, IN, and US, it is US. According to that, like Germany also had a tag. So we used to tag developer based on the region. And then we had a Lambda function. So what this Lambda function will do, we had scheduled this Lambda function for every 1 hour. So what it does is, so first it checks what is the local time in each region, India, Germany, and US, and China. And if it reaches, let's say 7 p.m. IST, so now whenever this Lambda function is executed, it sees that, okay, so now 7 p.m. IST, and then it retrieves the instance IDs based on these particular tags. First, it will gonna collect the EC2 instance IDs based on this local build tag. And then within that also, it scans the region tag and whichever has IN. and then it collects the information and then it stops. Likewise, let's say now Lambda function has triggered in the next hour and it identified it's a 7 p.m. Time in Germany. So then it retrieves the instances in the Germany region it used to stop it. So this is where to manage these EC2 instances properly. So we had used a Lambda function depending on the time. So depending on these labels, we could able to read the instance IDs and then we had stopped it. And in this Lambda functions also, there is no problem if even if it is a new EC2 instance is added, we used to add the tags, right? So we don't need to explicitly inform Lambda function because it uses the query of EC2 instances so that even when we create a new instance, will be considered for this particular managing EC2 instances. And that's all for this particular video. And if you have liked the video, please do like, share, and subscribe. Thank you. Have a great day.